So basically we have just went through a very basic understanding of artificial intelligence, and let's come to a point that what is the basic difference between a traditional computer task and artificial intelligence. Now, I have just listed the activities under cognitive task, right? However, in general, you will listen several terms like artificial intelligence, machine learning, deep learning in any technological discussion. Now here the question comes that are they really different or same? If they are really different, then where is the difference? If we talk about AI, I mean artificial intelligence, the goal of AI is to create a computer system that exactly behaves like a human being to solve complex problems. Whereas machine learning tries to understand the pattern among the data and utilize the knowledge to predict certain outcome. So this particular statement looks little confusing for you, I think. Maybe. So let's try to understand in a bit uh, different way. Like as you can see in the right hand side of your screen over here, so let's take this particular pointer, and you can see here in the right hand side you have a Venn diagram where AI is present in the outermost circle over here, and ML is the inner one, I mean machine learning, and the most inner circle is the deep learning, right? Anyway, so we will talk about the deep learning in later phase of the course. For time being, let's concentrate up to machine learning only. Okay, so if you take a close look on the Venn diagram, you can easily understand one thing, that is all the technique of machine learning is somehow basically a part of artificial intelligence, right? Because machine learning is inner circle, as simple as that. You have that knowledge, but there are some cases definitely which can be considered as artificial intelligence but not machine learning. For example, in this sector or in this part, there is something which is AI but not ML. Because, now why I'm saying this? Because when researchers first created artificial intelligence or just started thinking about the artificial intelligence, they didn't have this machine learning in their mind. I mean, what does it mean? That means artificial intelligence can be developed even without learning patterns or hidden patterns in the data. So, what can be an example? I mean, an example for the use of AI without ML are, say, for example, rule based chatbot. Rule based chatbot means you will ask something and based on that you will get some reply. So there are some rule and based on that you are getting reply and do some operation or take some decision. Another example can be like if you take hundreds of medical doctors and each spend hundred of hours dealing correlation between symptoms and disease. If you then pack the knowledge into an easy to use machine, that's what actually you can say AI without machine learning. What does it mean? Mean we can say try to find a correlation between, say for example, the symptoms and the disease. So if you have these symptoms, so you are highly correlated with this type of disease or this type of disease or that type of disease, something like that. So for example, you have n number of diseases in one site and m number of uh, say symptoms in other site, and some of the symptoms is common for some of the diseases, but some symptoms is very highly crucial for some particular disease. So naturally that particular symptom and that particular disease will be highly correlated. Similarly, some symptom and some disease will be very low correlated, and based on that we can take correlation values, average correlation values with respect to some symptoms with some set of diseases, and based on that we can say that okay, if you have this symptom, and if this symptom is very high, this symptom is very low, then we can say there is a high chance to have this particular disease, something like that. In a very layman term I'm saying. This is also a very, you can say a artificial intelligence system, but there is no such learning hidden patterns in the data. So it's not a machine learning, but it's AI. Anyway, in case of machine learning, the correlation or rule, whatever you say, I mean, that we have saying, what happened actually, the difference is like if I want to design a machine learning system, which will do the same thing. What basically we do, we feed this particular correlation, that what we are just talking about, to the system to adapt predictive behavior based on unseen input. Unseen input mean, it means that assume that there is a box, a hidden, I mean whatever present within the box we don't know. Within the box I don't know. And the box represents some machine learning box. In the input of that box, we will feed those correlations of say, you know, disease and the symptoms. And this box will learn the pattern present within the relation, within the data. So whatever correlation that we are actually trying to find out by ourselves will basically realized by the box itself and make a prediction for some unseen input, means some unknown set of symptom or some combination of symptom and disease or something like that. That is what exactly what you can say machine learning. So that means you can say that is an advancement of artificial intelligence to some certain consent, I mean certain extent, right? So let's see some example of that. So if you see here, as you can see in the top part, it's very a simple rule based system, right? If you have a temperature something like less than or greater than some particular value, or if you have some particular infection or some pain, based on various symptoms, as just I told you that we have some correlation, and based on that there is a possibility to give some advice or do some task. So that is a part of, you can say, AI. But in case of machine learning, if I just have a try to understand a example, just what I said in few minutes back, that let's take a shopping website. You select some product and the shopping website will recommend some product to you. How it is recommending? It is actually recommending based on your previous searches in that website, and also based on your previous buying history. So what this shopping website is trying to do, it's trying to understand the pattern of buying product by you, what you like, what you don't like, something like that. That means there is some pattern. Maybe this pattern is not possible to realize with simple simple searching. It is not possible to realize, but there has some pattern maybe, and that pattern definitely is able to be captured by the website, and it's recommending the product. And you see, and if you look into this point, you will see that whatever product they are recommending is not exactly what you don't like. Actually, you like those products. Maybe you are not buying at that moment, or maybe you are keeping that one, some product, for later buy or something like that, but you cannot reject that every time. So there is some pattern, and that actually the model which is present within this shopping website is trying to is capturing correctly for you, not only for you, for all the people who are buying some product from the website. So this is what a very, you know visible difference, you can say, between a traditional computer task, I'm sorry, between traditional computer task and artificial intelligence. Now let's try to realize it in bit more detail. Is this clear till now? Hello. Okay. So we have just seen some examples of traditional computer task versus artificial intelligence. Now, in case of traditional computer programming, we write a set of rules in form of complex logic that generally we are habituated to write programs. The program can be bubble sort, can be a searching, can be storing some data, or anything, right? These traditional programs accepts only a specific set of inputs and produce some result, right? Now here you observe one thing: the internal logic remain unchanged over time, that I just said, right? Whatever you are, the program that you are writing right now, right, program for say searching a data or maybe sorting some set of data, that logic remain unchanged over time. So whatever input that the program is expecting, if you give, it will produce the output in the same way over the time. Now there is a, drawback for this case. Like that mean, if the size of the input increases suddenly, then the logic may fail to produce expected result for many inputs. What does size may increase mean? Mean that in case of bubble sort, say, for not bubble sort, I mean, say, in a particular program, it is defined that it will accept this n number of inputs. You cannot give less than an input, even you cannot give more than an input, right? If you do that, the program will fail, will not be able to give you good result, I mean correct result. Now practically, it's a limitation. I mean, if you want to do that, if you want to try to get a output for new set of inputs having larger data, in that case what you have to do, in that case you may need to make a logic more complex, which need to rewrite the program. right? So let's take a simple example. Like, for example, you say you are creating some searching of some particular element from an array, something like that. You need to give only one data, that's all, which you want to search. Now, in short, what you can say, we can say that these traditional programs are not scalable. Scalable means they are not expandable with larger input. Not, you cannot squeeze them with smaller input, so you cannot adjust. It's fixed. So, also in other words, you can say the program is not flexible enough to adapt its rule based on input. Just what I have written here. That what if the input changes? Traditional program is not scalable. So what to do in this situation? You see, to overcome this limitation, let's try to find the answer of a question. What question? What if somehow let computer learn new knowledge by looking at the data? What does it mean? Try to understand it very, you know, you know, give an attention on this particular point, because this is going to be vital. Like, for example, for a computer playing chess game, I mean, I want to, what I want that computer will play the game, the chess game. Okay. Is it possible to design future strategy based on previous experience, just like human being? Because if you start playing chess, what will happen? Based on the experience that you have on chess playing, experience means the previous try and errors that you encountered in previous uh, you know uh, games with someone else. Based on that experience, actually you try to, you know motivate my try to change your code, change your strategy, change your strategy so that you can try to win, right? That's why my question is that, for a computer playing chess game, is it possible to design future strategy based on previous experiments, just like human being? Now, to answer this question, let's look into a diagram which looks like very simple. The diagram that you can see over here, this diagram. It's looking very simple, but it's very powerful strategy. Remember. So what we can do in this modified approach is that instead of set some predefined rule, we can deduce a set of rule based on a set of pairs of input and output. I mean, the result. So this can be an input. If the input is this, then the output will be that. Something like this, what I'm saying. And if you have this particular example in your hand, that for this input, this can be an output. For this set of input, this can be an output. So if you have, these are actually, I'm saying as an example. Okay, so if you have this set of examples, I mean, these examples can be fed into the machine learning black box, and this machine learning black box will extract the pattern in the data and find the relation between input and output somehow. How it will do that I still don't know, but we will, day by day we will understand that how. But before how, try to understand the context of this. That is what actually right now we are trying. Okay, so the pattern will be automatically represented in form of some level of knowledge or some set of rules. The pattern that every time I'm saying, that is some set of rules. So what we can do with these rules, that actually we have extracted or got from the machine learning black box based on those examples. What we will do that? In future, we can utilize that knowledge or the set of rules that I'm just saying to find the result of some unknown inputs. Now, naturally, here a question may come in your mind is that what is the difference with traditional computer program? The biggest difference is that in previous approach there was no scope of adapting the knowledge for new inputs, right? But here we have a scope of adaptation, because if I want to have if I want to make the computer or make the machine learning model more intelligent for more rigorous inputs, what we'll do, we will actually train it or teach the machine learning box with those set of examples of new type of data. Naturally, the rules will get updated, the more rules will be added over there. If more rules added, that means that particular machine learning black box will be more intelligent for predicting more rigorous data in future, right? Like you can easily relate this situation by your own learning strategy. Like for example, I'm right now teaching you, like you learn a mathematical approaches to solve problem using variety of examples, right? You don't take only one problem, and nobody will say that just by seeing only one example I have learned everything. It's not possible. We don't do that. What do? We try to solve problems with variety of examples, but that does not mean in future you can only solve those problems that you have seen, that you have solved. Rather, you can solve any problem which is similar to the example but not exactly the example. Obviously the examples you can solve, but similar type of problem also you can solve, right? So here we are calling it is a black box because, as I told you, that till we don't know exactly what is there which helps the machine to learn, right? As we will move further, we will open the black box and trying to understand what is the inner component present.